This last page, we've got a couple of problems dealing with partial derivatives. So here's this first one. We're just asked to find the partial with respect to x. So that means we just ignore the y as though it's a constant. So when I look at that, I can see this is a product. As far as the x's are concerned, I've got this x, and then I've got an x in there with this e. So it's going to be the derivative of the first factor, which I'm going to just say that's the x. It's the partial derivative times the second, plus the derivative of the second one times the first. So there's my product rule. And then I'll do these derivatives. So partial derivative with respect to x of x is just 1 times this e to the xy. And then on this one, when I use my rule, I got to use my chain rule from calculus 1. You take the derivative of e, which is e, put your inside function back in, and then you have to multiply by the partial with respect to x of that inside function. And then there was this x that was there from the product rule. So I've got e to the xy. We've got one more derivative to take, so we'll go do that. Derivative of xy with respect to x is just going to be y. So to finish this up, I can factor out an exy. What's left here is a 1, and there's an xy left there, or a yx, whichever you prefer. Okay, and then number 10 says to find all second partial derivatives. Well, you have to find the first partials to get the second partial. So I'm going to take the partial with respect to x first. That's the derivative, if you want to write it. If you don't have that one memorized, which probably should, it's the one that shows up a lot. But anyway, you can write that as y times x to the minus 1. So taking the partial with respect to x, I get minus 1, x to the minus 2. So it's minus y, x to the minus 2. We'll leave it like that, but that, if you want to write that in a nicer way, that's that. It's probably best to leave it here because we're going to take another derivative in a minute. And then the partial with respect to y, again, if you want, I can just do it here because derivative with respect to y just ignores the x, and so I just get derivative of y as 1. So I just get 1 over x. Okay, then I want the second partial, so let's do the second partial with respect to x. And that's this one with respect to x, so it's best to just use it here. I'm going to bring the minus 2 in front to get negative times negative 2, so that's going to be positive 2y, and I'm going to reduce that by 1 again, so x to the minus 3. Now this time I do, since I'm looking for the second partials, I do want to get rid of the negative exponent to write this as 2y over x cubed. So there's your second partial with respect to x. Oh, my second partial with respect to y, that's the derivative of this one with respect to y. Well, there is no y, so that's 0. And then I want the mixed partial. Just take the partial with respect of x with respect to y. So that's either one of these, but let's just say that's this one. And I can see there's only a y right here, so it's just going to be minus 1 over x squared. And just to be complete, we have to write this, and we know the answer is supposed to be minus 1 over x squared, and we can see it's the partial of this one with respect to x. So that is going to give me minus 1 over x to the minus 2, which is minus 1 over x squared. They are supposed to match up for our basic functions, and they did here. So anyway, there's my second partials, are all these.